Yeah. In this video, we are going to discuss about problems related to series RL circuit. Already we have completed two problems, and this is the third problem. Yeah, the problem is problem number 3. A coil has a resistance of a coil has a resistance of 4 ohms and an inductance of 9.55 millihenries. Full stop. Calculate first bit the reactance and second bit the impedance and third bit the current taken from 240 volts, 50 hertz supply. 240 volts, 50 hertz supply. And full stop. Next, determine determine also the phase angle between the supply voltage and current. Supply voltage and current. Yeah, this is the problem. Yeah. And first, understand the problem clearly and what is the data given in the problem and what we are going to calculate, what they are asking to find. Yeah, first, a coil has a resistance of 4 ohms and an inductance of 9.5 millihenries. Means from this, it is a series RLC circuit, right? And full stop. Calculate first bit. We need to calculate the reactance. Means we need to calculate inductive reactance XL. And second bit, impedance. Means it is series RL circuit. The impedance of the circuit Z is equal to R plus JX. And third one, the current taken from a 240 volts, 50 hertz supply. And we need to, here in the problem, they are giving RMS value of voltage. Therefore, we need to calculate RMS current. That is, IRMS is called V by Z. Okay. And also determine the phase angle between the supply voltage and current. First, based on the problem, we are drawing the circuit. It is series RL circuit. R and L. The supply voltage they are giving P is equal to 240 volts. Remember, this voltage is RMS voltage and the frequency is 50 hertz. And we need to calculate IRMS. We don't know the current. And the R value is 4 ohms and inductance 9.55 millihenries. 9.55 millihenries. Okay, and solution. First, we need to write the given data. What is the data given from the question? Given data, right? A coil has a resistance of 4 ohms, means resistance of the coil, resistance of the coil R is equal to 4 ohms, and an inductance of the coil L is equal to 9.55 millihenries, and then convert this millis into henries. It is 9.55 into 10 power minus 3 henries. L is equal to 9.55 to 10 power minus 3 henries. Yeah, and also given RMS value of applied voltage, RMS value of applied voltage V is equal to 240 volts, and the supply frequency F is equal to 50 Hz. This is the data given from the question. Yeah, first bit, we need to calculate the reactance. Means this is inductive reactance. First, we need to calculate inductive reactance. First bit, inductive reactance, that is XL. Inductive reactance is nothing but XL. We know XL, L is equal to omega L, right? And omega is nothing but 2 phi f into L. Just substitute the value of frequency and inductance here. 2 phi into f is nothing but 50 and L is nothing but 9.55 into 10 power minus 3. Yeah. Then calculate inductive reactance. Two 5 into 50 into 9.5 into 10 power minus 3. Yeah. Then inductive reactance is 3 ohms. Inductive reactance 3 ohms. Inductive reactance is 3 ohms. And the second bit, we need to calculate the impedance. Second bit, we need to calculate impedance in the circuit. Second bit, impedance. Impedance Z. Okay. And it is series RL circuit. The impedance of the circuit Z is equal to impedance of the circuit Z is equal to R plus JXL. Okay, impedance is equal to R plus JXL. Then what is the value of R? 4. And what is the value of XL? J 3. This is the impedance of series RL circuit. and this is in rectangular form. And we need to write z as mod z at an angle phi. Then we know the magnitude of z and phase angle. And mod z at an angle phi, this is the rectangular form, and this is polar form, and this is the polar form, and this is the rectangular form. We need to convert a rectangular to polar, rectangular to polar. Yeah, otherwise right here, this is a rectangular and this is polar form. Polar form. Yeah. And by using calci, it is easy to calculate the values from rectangular to polar. Yeah. Then z is equal to, by using calci, I'm just converting rectangular coordinates into polar coordinates. Then I'm selecting the calci, I'm selecting shift and then select polar. Okay, I want polar values. Then I'm selecting polar. I need to enter the x and y values here. X value is 4, then y value is 3. Then I am getting the magnitude of impedance is 5 at an angle 36.86 degrees ohms. And this is the impedance of the circuit. Both values are correct only. If you write this one, it is also correct, and this is also correct. Both are correct. Z is equal to 5 at an angle 36.86 degrees, or 4 plus J 3 ohms. Better to convert rectangular to polar. Then it gives the phase angle also, phase angle between voltage and current. Okay. Then next bit. What is the next bit? Current taken from the supply. Means we need to calculate RMS value of current. Current taken from the 240 volts 50 hertz. Current taken from the 240 volts 50 hertz supply. We are calculating RMS value of current. RMS value of current. That is capital I is equal to V by mod Z at an angle phi. Mod Z at an angle phi. And then V is nothing but 240. There is no angle of voltage. Just we are taking 0 by what is the value of impedance phi at an angle 36.86. Okay, and from that we are writing 240 by phi at an angle minus 36.86 and taking denominator to numerator. Then it is minus. What is the meaning of minus angle? Current is lagging voltage by minus 36.86. Remember, it is 240 by 5. And then current I is equal to 48 at an angle minus 36.86 degrees amperes. Here, and this is the value of current. And also determine the angle, phase angle between voltage, supply voltage and current. And fourth one, we need to calculate phase angle. Phase angle between supply voltage and current. That is phi is equal to direct unit, right? Or otherwise use formula phase angle tan inverse phi is equal to tan inverse of XL by R, or from the impedance we are calculating phase angle, or here from the current we are considering the phase angle, or phase angle phi is equal to 36.6 degrees, 36.86 degrees. And here the minus sign indicates I lags V by 36.86 degrees. I lags V by 36.86. And find from the values by substituting tan inverse of XL by R. XL is nothing but 3 and R is nothing but 4. And we are getting same value, 36.86 only. 36.86 degrees. This is the phase angle between supply voltage and current. Supply voltage and current. Remember, whatever the answer you are getting, just highlight the answer with a different color. Then it is easy to identify the answer. Then it is very clear. Okay. Thank you. Is it visible? This last value, phase angle between supply voltage and current. Phi is equal to tan inverse of XL by R, or phi is equal to, or already we are calculating phase angle, that is 36.86, or you need to substitute the values of XL and R, then we are getting same value. Is this clear? Yeah, thank you.